Okay, welcome to our first look at the Monster game code. And in this little intro, we're going to look at the game, and we're going to look at structured and OOP versions of the code. So, what do you need to do first? Ideally, you will have already downloaded the zipped Visual Studio project folder. If you're working in Python, you'll need to have the two separate Python files. There's also two versions of the pre-release information. They are almost identical, but they're not quite. Then I need you to run the game several times, make sure you've played it, got your head around it, and also make sure that you've stepped through the code, looking at the flow through so that you can see how the game works. Well, let's have a very quick overview of the program. So Monster is a classic 2D bird's eye view game, and if you're familiar with Zelda, this is what the very early versions of Zelda looked like, and Monster is almost identical. I mean, in a sort of console way. But very, very early console-based dungeons did work like this, so it's the same sort of idea. Rather than having to find whatever Link had to find, you've got to find a flask. If you've read the pre-release, you know that find the flask wins. However, if you fall into a trap, you wake a monster, which will then seek you, and you've got to really you've got very, very limited number of moves before it will eat you, because the monster moves twice as fast as you do. So let's have a quick run through the game for real. The original version comes from 2012, and that was in the Year 1 Comp 1 exam, and that was the structured version. And the OOP version comes from the current version of the AQA's syllabus, and that is the specimen paper. So you've got two versions to play with. I've created a fairly boring menu system which will jump you between the two, just so you haven't got to have two programs running, which is why there's monster struct and monster VB files, so you can see and move between the two bits of code pretty quickly. What I would say is your next benchmark will be on the OOP version of the code. But there could be questions about how is the OOP structure different to the structured version of the code. Well, let's run it. Bosh. And you can see it says what versions you want. It almost doesn't matter, they're almost identical. The structured version has got the ability to load and save the game. At the moment, the OOP version does not have an option to load and save the game. Other than that, they are almost identical. New game positions all the objects into a random position. The training game has got a fixed set of positions, so that if you know where to look, you can. Oh, I've woken up the monster. It's about to eat me. Unfortunately, I hit a trap, but then I let the monster get really close to me, and then I found the flask, because on the training game you know where it all is. So that's basically a quick overview of all the features of the game. Yeah, it is that simple in a quick run through. So let's get out of here. Obviously you're going to read the pre-release to get a bit more careful run through of the game, but that's the rough gist. Right, so very, very, very quick run through the code. I do not want to turn this into a long, boring synopsis of the code. Right, let's lose my little menu system and let's quickly run through. There is a structure to start with, and a few constants. And we're currently looking at the structured version of the monster code. You can probably guess what these are. It's just X and Y coordinates. And you can see there's some constants here, and you can probably guess that that's the grid size. If we look at the main, you can see that we've got the various options, but let's just have a quick look, and you can see that we've got quite a nice structure here of setup game and play game. Within main, there's a wodge of variables that are local that then get passed straight into setup game and also get passed into play game. So some of these you're probably suspecting are going to be by ref. Let's just quickly go to setup game, and we can see that I'm just going to make this slightly bigger. So we can see that we've got all those parameters, almost all of them being called by ref. And you can see that the game is relatively straightforward. We've got something called reset cavern, and we pass the cavern to it. Cavern, you may have noticed, is a 2D array. I'm assuming you can guess what that does. I'm assuming you can guess what reset cavern does. If you don't, you can always look at it yourself. If it's a new game, what on earth's new game? So we've got to go over here and say, oh look, new game was a boolean that got passed to it. So, where are we? We've got the player position being set and the monster weight being set as well as false. Again, hopefully it's quite nicely set up in terms of names. We've then got set position of item for traps, the monster and the flask, and then weirdly it sets position of item for the player as well. So you need to, this is obviously quite an important subroutine. I'm going to let you look at that in more detail. I will do a little video on it, but you can look at it for now. That is setup game sorted. Go to play game. You can see this is the main bulk of the code. And as you'd expect, it's held within two loops. One loop, the outer loop, is until you have, until you've found the flask or you've been eaten. Or you've got this weird thing, move direction equals M. So we need to get a head round that. You've got get a move, check a valid move, and as long as it isn't this M, which will come in a minute, then you're going to make a move and then redisplay the cabin. Then all the rest of it is handling the outcome of that move. So it's pretty much what you'd expect for a turn-based game. If we compare that really quickly to the OOP version, we don't have the same sort of structure. We've got lots of things called classes, which I'm going to explain another point, but we've still got a good honest submain, and we've got a couple of subroutines within here that are mainly just handling this bit, but effectively we've got something called my game, new game, and that will run within game this procedure. The only way you're going to get your head around it is by stepping through the code and having a look at it, but the basic gist is you can have a look at that, and you can see that we've got this randomized thing, but we've also got setup game and we've got play. So we've got very similar named boards, and actually within game we've got very similar structures of code. I'll be honest with you, this game could have been put more heavily into the paradigm of object-orientedness, but it's not bad. I'm going to stop there. That was just a very quick run through the code. I'm aware that we haven't done any OOP yet, so this is just an introduction, because it's far easier to talk about the object-oriented paradigm if you've seen some OOP code. Even if you don't understand it, when you step through it, you can see, oh, I've got exactly the same constructs of selection and assignment and iteration loops. It's all the same, it's just how we're actually going to structure that code and how we're going to build it up. It's also much more useful to do OOP in a sizable program, because when we're doing lots of little programs, it's very hard to see the benefits of OOP. Right, what do you need to do? You need to make sure you understand all elements of both versions of the code, and I want you to try and note down the differences. Almost start to create a set of questions, that things that you don't understand about OOP, and you'll see that in the next couple of weeks we will be learning about how to program in OOP. We'll be doing shed loads of little examples, and we will also be applying all those skills to the monster program. I hope you found that useful, and we will go through any questions you have on the tutorial.